Good morning, all. This is Satish Kumar, Assistant Professor of EC Department. Now, let us see the classification of signals and systems. In this C, we can going to see about the continuous and discrete time signals. See, standard signals are represented in both continuous time and discrete time signals. Continuous time signals are the variable of time is continuous. A speech signal as a function of time is a continuous time signal. Discrete time signal is the variable of time is discrete. The continuous time signal can be represented in terms of sine wave with respect to time and amplitude. The discrete time signals are also as shown with respect to n and x of n. Next one, the types of standard signals are unit step signal, unit impulse signal, unit ramp signal, complex exponential signal, and sinusoidal signal. Now we can see the unit step signal. So unit step signal can be represented in both continuous time as well as discrete time. For continuous time, u of t can be denoted as 1 for t greater than or equal to 0, 0 for t less than 0. The graphical representation can also be shown for 1 for t less greater than or equal to 0. Discrete time signal u of n is equal to 1 for n greater than or equal to 0, 0 for n less than 0. The graphical representation of unit step signal can be also be n from 0 to infinite. Next one, unit impulse signal. Del of t is equal to 1 for t is equal to 0, t 0 for t should be not equal to 0. In terms of discrete time signal, del of n is equal to 1 for n is equal to 0, 0 for n should be not equal to 0. The graphical representation of unit impulse signal can also be shown. Next one, unit ramp signal. See, continuous time signals of unit ramp signal is R of t is equal to t for t greater than or equal to 0, 0 for t less than 0. The continuous time is a linearly growing function. In terms of discrete time signal, R of n is equal to n for n greater than or equal to 0, 0 for n less than 0. The unit ramp signal of discrete time representation has been given. Next one, exponential signal. See, exponential signal is defined as x of t is equal to a into e power at, whereas is the amplitude. It can be represented in terms of DC signal, exponentially growing signal, and exponentially decaying signal. When a is equal to 0 means it is nothing but decaying signal. Greater than 0 means it is the exponentially growing signal. When a less than 0 means is exponentially decaying signal. Next one, complex exponential can be defined as x of t is equal to a into e power st, where s is a complex variable. It can be represented as sigma plus j omega. In terms of s, you can substitute sigma plus j omega. Therefore, it can be represented as a into e power sigma t into e power j omega. It can be represented as cos ohm t plus j sin ohm t. The graphical representation of exponentially growing cosinusoidal signal and exponentially growing sinusoidal signal has been given. Next one, real exponential signal is defined as x of n is equal to a power n for n greater than or equal to 0. Then a power n into e power j omega naught of n is equal to a power n into cos omega naught of n plus j sin omega naught of n. The real part of n is given by a power n into cos omega naught of n. Imaginary part of n is a power n into sin omega naught of n. The graphical representation of both real part and imaginary part can be shown in the figure. Next one, continuous time sinusoidal signal. Cosinusoidal signal can be represented as x of t is equal to a cos ohm t plus phi. And then sinusoidal signal can be represented as x of t is equal to a sin ohm t plus phi. See, graphical representation of cosinusoidal signal has been given. And sinusoidal representation of graphical representation can also be given as x of t is equal to a sin t. When phi is equal to 0 means x of t is equal to a cos ohm t cosinusoidal signal. In sinusoidal signal, sigma is equal to 0 means x of t is equal to a sin ohm t. Next one is DG sinusoidal signal. Cosinusoidal signal is defined as x of n is equal to a cos omega of n. Sinusoidal signal can be defined as x of n is equal to a sin omega of n. The cosinusoidal and sinusoidal graphical representation can be given with respect to n or x of n. Now we can see the relationship between unit step and unit ramp. Unit ramp signal is t for t greater than or equal to 0, 0 for t less than 0. Unit step u of t is equal to 1 for t greater than or equal to 0, 0 for t less than 0. See, differentiating r of t with respect to t means d by dt into r of t is equal to, we can get the unit step signal. Therefore, d by dt into r of t is equal to u of t. D into r of t is equal to u of t into dt. Therefore, r of t is equal to integral of u of t into dt. Next one, unit step and impulse. Step function u of t is equal to 1 for t greater than or equal to 0, 0 for t less than 0. Del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. Differentiate u of t with respect to t, we can get it as your u of t is equal to integration of del of t into dt. Now we can see the assessment. List the classification of standard signals. It can be classified into unit step, unit impulse, unit ramp, complex exponential, and sinusoidal signal. What is the unit step signal? U of t is equal to 1 for t greater than or equal to 0, 0 for t less than 0. Standard signals are also called as elementary signals. Define unit ramp signal. Unit ramp signal can be defined as R of t is equal to t for t greater than or equal to 0, 0 for t less than 0. Unit impulse signal is denoted as del of t. Standard signals can be represented in both continuous time and discrete time. The relationship between the unit step and the unit ramp is R of t is equal to integral of u of t into dt. What is mean by sinusoidal signal? It can be represented by cosinusoidal signal and a sinusoidal signal. X of n is equal to a into sine of omega t. Cosinusoidal can be defined as x of t is equal to a cos omega of t. Thank you.